Hey guys, welcome back. So we get to program our ESC using our Hobbywing LCD program box. So to get it connected, we hook our cable up right into the port here on our ESC. As you can see, line those signals up with the positive, the negative, and the neutral wiring. And so to get this turned on, we'll just hit the power button on the ESC. Little red switch right here. And that gives us power. So this is a highly programmable ESC. There are 5 parameters which we can program here. We have general settings, throttle control, brake control, and timing. And then there are subsets inside of those particular parameters. As we hit the enter button, this gives it a chance to get acclimated to the ESC. And so here, parameter 1A, we've got running mode. So you can select what type of running mode you want. Initially, it's set to forward and brake. So I have it set to forward, reverse, and brake because I'm in practice mode, but during competition times, I will be setting it to just forward and brake. And so it's going to select. Second one is the reverse force. This is still the first parameter in the general settings. We're in brake reverse force. 25, 50, 75 to 100% reverse power. Be mindful how much reverse force you give to your car. Lipo cells. This enables you to program for different lipo cells. You can do 3S, 4S, or you can do auto calculation where the car kind of just determines which kind of battery you have based off of your connection. But sometimes what happens is if you don't have a fully charged battery and you connect, it might think that the battery is a different one. For example, if you connect a 3-cell battery that's not fully charged at 3 cells, it might interpret it as a 2-cell battery and affect power distribution. So for that matter, we want to set our cells to the correct ones that we're going to be using and running in the vehicle. And for this particular vehicle, I'll be using 2 cells. Voltage cutoff. So the standard cutoff is at 3.5 volts per cell. So on a 2-cell battery, that's going to be 7 volts. But to maximize your car's ability to use your battery to the full potential, we're going to be using it to the 3.2 volts per cell. When you take it down past 3 volts, you enter into that dreaded low voltage cutoff zone where it might be hard to start charging your battery again. And so to stay clear of the 3.0 volts, we'll just drop it all the way down to 3.2 volts per cell. So at 2 cells, that's 6.4. At 3 cells, that's 9.6, and so forth, because each cell will use 3.2 volts. Here we have the ESC Thermal enabled, and we have motor thermal enabled. Those two kick in when the motor or the ESC gets too hot. In that case, something's going wrong when it is, but we just do that to protect the ESC. BC voltage, this directly affects your servo power. So usually you can set it at 7.4, but if you're running a 2-cell battery at 7.4 volts, you might get the quicker speed on your servo, but the battery, as it begins to be used and drains, it won't be able to sustain that 7.4 voltage output, and so then that messes up the ESC. So that's why we set it at the 6 volts. That way we still have a range and we still have some voltage going to the battery that can be used by the ESC. But at the higher cell, so a 3-cell battery, you can definitely set it to the 7.4 volt. Smart fan enabled. Once it gets hot, smart fan kicks on to cool down the ESC. It won't turn on until it reaches that predetermined heat level. It's full sensor mode. So you can go full, you can go on the hybrid. I have the full sensor. This allows for full sensor capabilities when using a Hobbywing ESC paired with the G3 Hobbywing motor. If you're running a different motor, the hybrid sensitivity is possibly used and a little bit more efficient. Motor rotates. Some motors, transmissions rotate in counterclockwise fashion. Some rotate in clockwise fashion. Set yours accordingly. We have the phase AC swap. What is that? So this enables you to do some cool wiring from your ESC to your motor, where you can switch the A and the C wire and wire them differently. Bringing the C wire to the A port and then the A port to the C wire and so forth. But you turn that on and make sure your wiring is done correctly to do that. Throttle rate. This talks about the sensitivity of the throttle. So the higher the rate, the more sensitive your throttle. So if you've got a heavy finger, maybe you drop the throttle initially, the rate, until you learn some throttle control. Usually with beginners and young kids, it's good to set the throttle rate lower, so that way they're just not pinning the throttle and not having any good control over their vehicle. As you gain control and experience, learn how to control your throttle, you can set the sensitivity to high, which is at 30, and that enables you a lot more control of your vehicle. The throttle curve is linear, or you can set it to a customized. Linear meaning that as you pull that throttle back, it goes faster and faster the more you pull. You can play around with this in the throttle exponential as well, where plus throttle exponential, there's a lot more sensitivity in the throttle earlier in the phase of the pull, and in the negative throttle exponential, there's a lot more throttle later in the throttle pull, closer to the base of the handle. Neutral range is set to 6%. Not a lot of cars have a good understanding of where neutral is in terms of on the throttle, so this gives you an opportunity to set that. We have initial throttle at 5%. Low initial throttle allows for the car to So we have initial throttle. This enables you to control the car's throttle force, usually on slippery surfaces. Coasting. So as we hit the throttle on the coast, on the transmitter, motor spins quickly. Once we release the throttle and the throttle trigger moves back to neutral, the car coasts. Usually there's a brake effect felt, where the braking system engages and slows the car down. Coasting allows you to not feel this braking effect. And so use this particular method, like in competitions, to allow you to enter into curves and corners a little more efficiently without feeling too much braking going on. Your drive frequency. At the higher value, it gives a lot more sensitivity to the driving, where the acceleration will be aggressive in the initial setup of the drive frequency. A higher drive frequency is smoother, but will create more heat to the ESC. The softening value. It allows users to fine-tune the bottom end and change the drive feel. The maximum driving efficiency at different tracks and conditions. The higher the softening value, the milder the bottom end. In the modified class, drivers often feel the power of the bottom end is too aggressive. So little throttle input usually brings too much power to the car and makes it hard to control at the corners. So Hobbywing created this softening function to solve this issue. So you have the softening range. Softening range to which the softening value starts and ends. So from 0 to 30% will be generated when the user pre-programs the softening range at a value of 30%. You got your RPMs. We have unlimited ability on the RPM. It's used to set the max RPM of the motor. Set this one according to the motor's abilities and the competition rules. So you got your drag brake percentage, or your drag brake force, right? So this is the braking power produced when releasing the throttle from full position to neutral position. This is to stimulate the slight braking effect of the neutral brush motor while coasting. Higher value, more brake force, lower value, less brake force. The brake force. So this provides proportional braking functions. The braking effect is decided by the position of the throttle trigger. It sets the percentage of the available braking power when the full brake is applied. Large amount will shorten the braking time, but it may damage the pinion in the spur. The brake rate. Brake rate control is adjustable from 1 to 20. The lower the brake rate, the more limit on the brake response. A suitable rate can aid the driver to brake the vehicle correctly. Gradually, you can set it to a high value to have quicker brake response. So the braking control. There's two options. You have traditional brake control and disc brake. So in the traditional method, just like traditional braking, you can use, and due to this tracking force being affected by the motor's speed, and can cause the braking to not be so linear or smooth. When you use the second option, the disc brake, the innovative braking method from Hobbywing, the braking force is not affected by the motor speed, which is better braking linearity and stronger braking force. Get your ABS force. So this parameter is used to adjust the braking force maintained by the motor as the motor stops rotating. The larger the value, the greater the braking force. Setting the value appropriately according to the traction can help improve the situation of wheel lockup and sliding. Disc brake curvature. This parameter is used to set the braking curve in disc brake mode. The higher the curvature, the greater the braking force in the front section. The smaller the curvature, the smaller the braking force in the front section. It can be set accordingly to the personal habits of the driver. We have brake frequency. The brake force will be larger and the frequency is low. You will get a smoother brake force when the value is higher. So choose this accordingly. You got boost timing, new feature here on this XR8 platform. So it's effective within the whole throttle range. It directly affects the car's speed on the straightaway and the winding course. The ESC adjusts the timing dynamically as per the throttle amount in the operation. Boost timing is not constant, but it's variable. Turbo timing. Turbo timing, this item is adjustable from 0 to 48 degrees. The corresponding turbo timing will initiate at full throttle. It's usually activated on a long straightaway. It makes the motor unleash its full potential. You have turbo delay. The turbo delay is set to instant. The turbo timing will be activated right after the throttle trigger is moved to the full throttle position. When the other variables are applied, you will need to hold the throttle trigger at full throttle position as the turbo timing initiates. We have the turbo increase rate. This item is used to define the speed at which the turbo timing is released when the trigger condition is met. For example, 6 degrees at 0.01 refers to the turbo timing of 6 degrees that the item is used to and will be released in 1 second, but the acceleration and the heat is higher when the turbo release rate is of a larger value. And the same thing with the decrease rate. After the turbo timing is activated and the trigger condition turns not to be met, the vehicle slows down at the end of the straightaway and gets into a corner, for example. Full throttle turns to partial throttle. The trigger condition for the turbo timing tends not to be met. If you disable the turbo timing in a moment, an obvious slowdown in the braking will be felt and cause the car to become, badly handled and lose control. So the ESC can disable the turbo timing at some speed and slow the car down, which will be linear, and the control will be improved. All this are done and used when you have the full sensor mode on. And so the last section, you have restore factory default, and you have your mode 1-0 timing. We have motor temperature, we have voltage minimum, which is 6.6 volts. So that's what's going on right here inside the ESC. As it's reading the max RPMs, it reads for you. And there we have it. Be sure to refer to your pamphlet when learning to program this thing and have some fun, take it out, give it a test. I want to thank you guys for joining me. Let's get this guy turned off. And I'll see you guys soon. If you found this video helpful, drop a like, subscribe, and turn on the notification bell so you can be up to date on the newest information that I'll be dropping. See you guys soon. Remember, bash hard, bash often, most importantly, bash safely. Until next time, guys.